Hi there, I am nurxie and this is the second part of the video on setting up slides. We stopped at the fact that we collected trackers, but did not flash them. In this video I will talk about the firmware, cell settings, calibration, and the first launch. Perhaps later I will make another video on the topic of upgrading trackers with answers to questions. So if you have something to ask about hardware or software, I'm waiting for you in the comments. We're done with the greeting, let's move on to the video. We write to Google Glory, go to the GitHub page of the project. On the GitHub page of the project, both the server itself, its installer and the source code for compiling the firmware for our microcontroller are presented. Download the server installer. Select the drivers that will be installed for microcontroller programmers. This point can be skipped if you have previously flashed microcontrollers through the programmer's TS-340 or FET 232. Of course, these drivers can be delivered later in the future, but now it is as comfortable as possible. During the server installation, you will need to install some modules before. It is advisable to install them in the same directory where we installed the SlimeVR server. After the successful installation of the SlimeVR server, we immediately go back to the SlimeVR project page on the Guide Hub and download the source code for the firmware of our microcontrollers. To download, click on the green button, download the archive and transfer the file from the archive to a convenient place for you. I'm transferring it to the desktop. Also download the Visual Studio Code. Visual Studio Code is a kind of code editor that comfortably supports additional plugins. One of the plugins that we will use is called Platformium. This is an analog of the Arduino IDEA, which is much more comfortable and much more convenient to work with. We go to the Add-ons tab, enter the name and click on the blue Install button. It may take some time, depends on your internet and on the performance of your computer. After a successful installation, it is advisable to restart the physical studio code and now we can open the directory with our project. After that, special modules for programming the ESP8266 controller will be installed before. By default, the firmware is assembled under 8266, but during the program you can change it under EP32. The main configuration of the board to which you will upload takes place just in the platform 0.eno file. Here we need to pay attention to two lines of Wi-Fi settings. To uncomment these lines, you need to remove the semicolon, replacing the inscription with ID, that is, the name of your network, the name of your 2 GHz network and also specify the password. It is desirable that the network name and password do not contain special characters. Exclamation mark, colon, period may not work correctly. We are trying to compile the firmware, we see the error of the absence of the guide system. Click on the link, or type in the Google Download guide and download the client guide to our computer. When installing the guide client, we do not change anything in the installer, we do not put any ticks, just click Next Install. After installing the client's guide, it is advisable to restart the Studio Code Visa again. After that, we will be able to compile the source code, firmware for the microcontroller. Compilation takes place by clicking a small tick at the bottom of the screen. Compilation is successful after sex inscription. If something went wrong, look for the answer in Google, typing, in fact, the error text. We go to the Dev SlimeVR page, where we can configure our tracker specifically to take into account the microcontroller, sensors, and an additional sensor. An additional sensor is used as an auxiliary for the rotation of the leg. I'll tell you about it somehow in the next video. Configure the sensor rotation angle if it is installed a little differently than the developers intended. The data is defined. This code can be generated by hand, but it is much more convenient to take it on the site. This code allows you to configure the operation of your tracker in some way for the future. This code does not change the tracker. It is going specifically for your project, for your sensors, and will work on all trackers of this type. If the sensor is installed rigidly in the housing and on the board, as in my case, I cannot change it in any way, and I have an error on the axis, it is advisable to go to the configuration file for the sensor and change the axes by inverting them. In my case, I had the Z-axis mixed up, which is why I had to add a negative value to the calculation. I want to say right away, if everything is fine with your axles, you don't need to change anything. If you have the sensor fixed gently on the wires, you can turn it inside the body of your sensor. In my case, the sensor is made on a rigid printed circuit board and is rigidly soldered into this printed circuit board itself. It is desirable that the axes of the tracker coincide with the axes of the sensor itself, that is, to install it as rigidly and directly as possible in the housing. After adjusting the defines and possible changes to the program code, we compile the firmware. It remains to connect the microcontroller and load the firmware into it. Initially, I forgot to connect to the microcontroller, which is why the first boot was unsuccessful. After the correct connection of the microcontroller, loading into the microcontroller itself takes literally 10 to 20 seconds. The firmware is loaded, the controller is ready to work. After each firmware, it should be calibrated. In my case, the Firmware i160 sensor requires calibration after each firmware, because the sensor calibration information is stored in the flash memory of the microcontroller. For proper calibration, we turn the sensor down, turn it on, wait 3 seconds, turn it back over and wait for the additional stadium to flash. After it started flashing, we have to turn the sensor absolutely on all axes. This is required for calibration of the gyroscope and accelerometer. Immediately after turning over the trackers, it is better not to touch them for a few seconds for the correct installation of the vertical axis. After successful calibration, the tracker will blink and connect to the Wi-Fi network. Calibration is over. We turn to the configuration of the SlimeVR server. At first, the program greets us with an offer to conduct a Wi-Fi network, but we refuse and move on to the next point of linking the tracker to the body. It is advisable to run a SlimeVR server already with all sensors connected. Go to the settings and set the preferred language. We check the developer mode in order to see the position of the sensor. We put the sensor exactly on the table, since it will be attached to our body. We press the restart button and now we see our tracker. It is important to note that the tracker in the app is turned to face us. Check if the tengash, roll and yaw match exactly the same way you move the sensors in reality. If one of the axes is inverted, check the program code and invert it if necessary, or we put trackers on ourselves, already all 5 pieces. We make a general reset. After that, we have to get into the pose of a skier and reset the mount. This is required for the perfect calibration of the way the tracker is attached to the body. I completely forgot to mention the calibration of the body proportion. This procedure should be performed after a complete reset and calibration of the attachment. This procedure will set the distance between the trackers, as well as determine the proportions of the body. This is an extremely important point, it cannot be skipped. We go up the chat and expose our correct growth, which we have in life. Before binding the avatar, we reset the sensors. Rather, we calibrate the full body from the menu. We match the white balls with our avatar, stand up straight, press 2 triggers and will. Slay works on our VRchat avatar. No one watches when replacing avatars. The accuracy of tracking may depend on both the calibration and the method of attachment to the body. I strongly advise you to make elastic fasteners on elastic bands and a Velcro plug, then the drift of the tracker relative to the body will be absolutely minimal. A rigid sling will not do. The project is alive and it cannot but please. My Telegram channel is the past of video slides. Good luck to everyone in the assembly. Look, there's a naked fury.